Imagine waking up one morning and finding yourself on Mars. How would you communicate with your peers on Earth? The future of humanity on Mars hinges on more than just survival. It depends upon our ability to communicate, to connect with each other, with equipment on the planet, and with mission control on Earth. Yet, the current communications infrastructure we have may not be up to the task. It's a bit like trying to stream the latest blockbuster on a dial-up connection, frustratingly slow and prone to interruption. Now, researchers are scrambling to find ways to upgrade our existing networks. But envisioning a future on Mars isn't just about enhancing what we have, it's about exploring the uncharted territory of the possible. And one such possibility that's currently under the microscope is laser communication. This is no ordinary chat system. Instead of radio waves, it uses light to transmit data, which means it can carry significantly more information. Yet this potential boon comes with its own set of challenges, like the need for precise aiming and the potential for upgrades to existing infrastructure or even new constructions. Another idea that's been floated is that of a separate internet for Mars. A red planet web, if you will. Currently, our communication with Mars is facilitated through the Mars Relay Network, a group of orbiters transmitting information via antennas pointed towards Earth. However, when humans finally set foot on Mars, a more robust system will be needed. Think ground-based antennas, orbital relays, and optimized data transfer. So, as we can see, the current Mars communication infrastructure has its limitations and needs an upgrade to cater to future needs. Indeed, the future of Mars communication is a fascinating topic, full of potential and challenges. The question remains, how will we ensure that even millions of miles away we can still say hello to each other? So what exactly is the present Mars communication system like? Well, let's dive right in. Currently, our communication with Mars is facilitated through something called the Mars Relay Network. This network is comprised of orbiters, essentially spacecrafts that orbit around Mars. These orbiters act as middlemen, transmitting information back and forth between Earth and Mars. The data is transmitted via antennas that are pointed towards Earth. This system works reasonably well for our current purposes, but it's not without its limitations. One of the most significant challenges is the time lag in communications. Since Mars is, on average, about 140 million miles away from Earth, it takes time for information to travel between the two. This lag can range from a quick 4 minutes to a lengthy 24 minutes for a one-way trip. Imagine waiting for half an hour to get a response to your text message. That's what we're dealing with here. Another limitation is the disruption caused by solar conjunctions. This is when the sun comes between Earth and Mars, which happens every 2 years or so. During this period, communications can be disrupted for a couple of weeks. It's like having your internet connection cut off just when you're in the middle of an important Zoom meeting. Lastly, the current system relies on radio waves for data transmission, which isn't ideal. Radio waves can only carry so much information at a time. This means that the amount of data we can send and receive is limited, which is a problem when you're dealing with something as complex as space exploration. Clearly, while effective for our current needs, this system may not be sufficient once humans land on Mars. The European Space Agency has a potential solution, the Mars Communication and Navigation Infrastructure, or MARCONI. As we delve deeper into the cosmos, the need for advanced communication systems grows. MARCONI is one such concept that aims to revolutionize how we communicate with Mars. It's not just about sending and receiving messages, but about creating an entire network that can handle the demands of future Mars inhabitants. At its core, MARCONI seeks to enhance the current Mars Relay Network. This network is made up of orbiters that transmit information via antennas pointed towards Earth. It's a bit like a cosmic postman, passing messages back and forth. However, with the arrival of humans on Mars, this system will need to be more robust. The postman must become a courier service, capable of handling increased traffic and delivering messages more efficiently. How does MARCONI plan to achieve this? Well, it's all about using the right tools for the job. This could involve the addition of ground-based antennas, orbital relays, and optimized data transfer. Each of these components could work together to create a stronger, more reliable network. Ground-based antennas could provide direct communication with Mars inhabitants, while orbital relays could ensure messages are delivered even when Mars and Earth are not in direct line of sight. Optimized data transfer could then ensure that all this information is sent and received in the most efficient way possible. Of course, this is all theoretical at the moment. The concept of MARCONI is still being developed, and there's a long way to go before it becomes a reality. But the potential benefits are clear. A more robust communication network could improve the safety and efficiency of future Mars missions. It could allow for more detailed data collection and analysis, enhancing our understanding of the red planet. And most importantly, it could ensure that our future Mars inhabitants are never out of touch. MARCONI could be a significant step in improving Mars communication, but there are other alternatives being explored as well. One promising alternative is laser communication, but what makes it so special? Well, laser communication offers a significant advantage over traditional radio waves. It can transmit a lot more data. Imagine trying to fill up a swimming pool using a garden hose and then switching to a fire hose. That's the kind of difference we're talking about. This could mean faster downloads, improved video quality, and more efficient communication between Mars and Earth. And it's not just a theoretical concept. As we speak, NASA's Psyche mission is putting this technology to the test in the vast expanse of space. By exploring the feasibility of long-distance laser communication, we're taking promising steps towards upgrading our interplanetary internet. However, like any pioneering technology, it's not without its challenges. For one, optical communication requires a high level of precision. The signal must be aimed with pinpoint accuracy, or the data could end up lost in space. This is akin to trying to hit a bullseye from miles away, not an easy feat. Moreover, switching to laser communication may require substantial upgrades to our existing infrastructure. The antennas we currently use for radio communication may not be up to the task. Alternatively, we might need to construct new infrastructure designed specifically for laser communication. Either way, it's a significant undertaking that requires careful planning and considerable resources. Yet despite these challenges, the potential benefits of laser communication are too great to ignore. As we look to the future of Mars communication, laser technology could well be the key to establishing a robust and efficient network. With its high data transmission capabilities, laser communication could be a game changer for Mars communication. Interestingly, our closest celestial neighbor, the Moon, could also provide valuable insights for Mars communication. You see, the Moon has been a testbed for various communication technologies over the years, and these experiments have provided us with numerous lessons. For instance, we've learned how to handle the challenges of communicating over vast distances, how to deal with time delays in transmission, and how to navigate the tricky terrain of celestial bodies. Moreover, the Moon has shown us the potential of using relay satellites for communication. These satellites, stationed around the Moon, have been instrumental in maintaining a steady stream of data back to Earth, a principle that could be applied to Mars. Additionally, the lunar surface has been a training ground for rovers, similar to those we hope to deploy on Mars. The challenges faced and overcome here could be invaluable in ensuring smooth operation on Mars.